Okay, so so I found this website called Aladin Lite, and I really wanted it because I have used it a lot of I have used it a lot of time before, but I've used it randomly when I didn't know how to use it. But now I know how to use it. So now I can explore technically anything I want in space. And all you have to do to find out what a thing is press this button, click the thing. If it says you can just click this button, and then you can click there, and then it says tet apps. Whatever is that? LPV. What's an LPV? I don't know. But let's just continue. So this is an infrared sky survey, and now you know why it doesn't look like the sky. If you're looking for a brighter infrared sky survey, then here you then here you go. But we're not here to discuss infrared. We're here to discuss all wavelengths. So let's start at visible light. Everybody knows what visible light is. Everybody has seen visible light. What we see with our eyes is visible light. So this is the Milky Way right here. Wait, and we have wait. Wait, let me see something. We have the Alpha Andromeda Galaxy over here, and the Magellanic Clouds, Eta Carinae, the Eta Carinae Nebula, and it's hard to name, and you can't name all of them. Let, wait, Duri Nebula. Let's just so so everybody knows what this is. But so let's go to other ones. Glimpse. Let's start with this one called Glimpse 360. Somehow it's somehow it just doesn't work. So let's go to Furby. This might look like an infrared survey, but it's actually in gamma rays. So yeah, this is actually gamma rays. It's not infrared. These three star things are actually pulsars. Let's see. So this one is the Crab pulsar, Jaminga pulsar, and the Vela pulsar. And there's one of them over up here. 3Z43. That's not a pulsar. That's a blazar. It's like a quasar, but bigger. It's like a quasar, but it's brighter, way brighter. Let's see what this is. PSR J1 836 plus 5925. That one is a pulsar. And now let's go to Swift Mad Flux. The only reason I hate this is it has very poor X-ray. It's an X-ray, but it has very poor X-rays. Look, a dot is this big. That's actually super big. If you know what degree, if you know what coordinate star coordinates are each dot is 1 degree wide, and that might be super small for people who don't know what this is. But for everybody who knows what star coordinates are, it's every dot is 1 degree wide. Look, Sagittarius A is supposed to be in more detail. This splotch over here is Sagittarius A. This little splotch. And also, if you can't see my mouse right now, it's this little splotch that I'm centering on. That blue splotch. So I like XMM. I personally like XMMPN much more because it's not so much super high, so high graphics that you won't be able to see the entire sky at one time. But it's not so low graphics that each one is 1 degree wide. So So this is the same, and yeah, this is exactly what this this is the center of the Milky Way. So we have a lot of pulsars here, but if we zoom in this singular area, this one of these is Sagittarius A. I don't know, one of these. Let let's check it in with very high graphics. Like, no, wait, not one of these. Wait, if you look at this one, this just seems like one star, one thing, and this seems like one thing. But in super high resolution, this is one thing, and this is actually two things. So now I remember this one is Sagittarius A. It has a lot of noise, so that's why it's pretty hard. So I don't know what the name of this is, but let's see. No, wait, it's actually CXOGC J1745440.6-2900015. That's a pretty long name, but let's continue. So see, I don't want it to be so high resolution you can't see the entire sky at once. In XMPN, you can see the entire sky at once, but it's not super low resolution like this. It's not this much low resolution, but it's not so high resolution that you can't see. Next, let's see Galax. So Galax data is actually very weird because it doesn't cover the entire sky. It has just that it covers the entire sky. It takes pictures of the sky in circles, and it just puts all the circles into one image. So takes a circle of the entire sky, and it takes it into one single image. So circles, you can't cover a square with circles with there being with you can't cover a square with circles with there being with none of the circles like overlapping each other. You can't cover a square with circles with none of them overlapping each other. Well, Galax did that. It's not a square like an oval, but Galax did that, and now there's these little patches. But still, it's a valuable X-ray source. It's a valuable ultraviolet source, and you can still see stuff with it. But it's hard to find stuff with it because it easily gets you distracted. But this is DSS2 blue. It is the same thing as visible as this thing is as the same thing is visible when it's captured under a blue filter and turned into grayscale. How weird is that? Got in a blue filter and turned gray. So good thing they didn't do that to the regular DSS too. This is something called Melinger, and the reason I really like it is it's pure data from Earth's ground. So the thing that because it's from Earth's ground, it doesn't have the highest resolution. Because it's from the ground, it doesn't have the highest resolution, but it's good when you're looking at what to find really good stuff, really big stuff. So and it's captured in brightly, so it highlights any dim object, and this was captured by a person, not a satellite. A person. Look at this. Copyright by a person. And this person took a telescope, a really good working telescope, and he captured the entire sky. And if he was living in the northern hemisphere, I do not know how he did the southern hemisphere instead, other than going to South America. This is Finkbiter. So Finkbiter is hydrogen alpha. Hydrogen alpha is not that much of a filter, but hydrogen alpha is actually very good, and it's not in the electromagnetic spectrum. That's a very weird thing. It's captured with hydrogen. It's not a part of the electromagnetic spectrum. So it's not like infrared, ultraviolet, visible, gamma rays, or X-rays. It's its own. It's captured with hydrogen, and it took all the hydrogen into alpha decay. It took all the hydrogen into alpha decay, and then used that data from alpha decay to form this. This provides valuable information about very big dust clouds. So this is one of the biggest dust clouds. This cloud here, that's one of the brightest, but there's a larger dust cloud surrounding the constellation Orion, but this dust cloud is harder to see and you cannot see it in the sky. Let's go to SDSS 9. So I accidentally changed the brightness. So SDSS 9 is SDSS 9 is still valuable data. It's actually very good data. It can It's very good data. So, but the thing about this is that it does not cover the whole sky, sky. So, so it's only good for observing things that are not in the area of. It's not. I don't know the name for it, but it's the area that's shrouded by the Milky Way. So it does not capture any of that. This is the same thing, DSS2, but under a red filter turned into grayscale. Again, why do people do that? This is VTSSHA. So this, so you know what I told you about fake miner? This is a lower level hydrogen alpha spectrum. You can't see the gas cloud. It's made to see smaller gas clouds. The gas cloud, but it's still a type of hydrogen alpha. This is pan stars. It has very good data. It was created by pan stars, and and people and there's even a comet named after pan stars. But so it has very valuable data on a small scale level, but sometimes the data can be a bit blinding technically. So the data is very bright. That's the thing. And look, so sometimes your eyes could get hurt watching this. So, and also, I don't know why there's a big splotch of things that I haven't known yet, but let's just continue. This is decaps. This is actually a mix between visible and infrared light. It's also like pan stars. Sometimes it can blind you, but it's still still valuable data. And also there are the tiny circles outside of the main detection area. But let's see this thing called decals, also known as DES for short. D D Also known as DES for short. Decaps is actually a part of decals or DES. So this is an ultraviolet spectrum. DES stands for Dark Energy Survey. So this is made for discovering four galaxies and is made and they created it to discover the secret of dark energy and dark matter. And then let's go to TUMAS. TUMAS is a regular type near infrared survey. You can see a lot of brown dwarfs and red dwarfs. You can see a lot of brown dwarfs and dim red dwarfs here. For example, these are red dwarfs. Next, let's go to Spitzer. This image of Spitzer only covers the large and small Magellanic cloud, wide the Eta Carinae Nebula, probably, and the main area where the Milky Way is. Spitzer is known for very good infrared data. This infrared data is actually is way higher resolution, but it only covers a small amount of space. This is all wise. All wise data is like two mass data. It's basically the same thing, but it shows smaller brown dwarf. This one is aimed for brown dwarfs. Two mass is aimed for red dwarfs and the smaller dinner stars. This is iris. This could also blind you, but it's also very valuable information. So, but sometimes it's way too bright. But 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 if you're discovering like if you want to discover like very dim infrared sources, this is the one for you. And finally, we have Akari. Akari is like is Akari is a good choice when you're blinded by iris. So it uses the same data as iris, but 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 not data that will make you blinded. But the thing is that it will have you only detects this bigger. It doesn't detect dimmer infrared sources. It detects things like this galaxy right here, Mizzier 101. Hey, the Andromeda Galaxy is somewhere here. It's Mizzier 101. The Andromeda Galaxy is somewhere near here. But let's. It's okay, but wait. Mizzier 101 isn't the Oh, the spiral galaxy. I don't know what this is, but that's it. That's technically